Welcome to Video 10 Transcription. First, we're going to do a brief overview of what we covered this week. If you remember, we covered the central dogma, which is the concept that RNA is made from DNA as a copy of DNA, and then proteins are made from RNA. The reason we have to do this is that there's the cell, and there's DNA inside the nucleus, which can't leave the DNA, so RNA has to be made so that it can be taken out to the ribosomes where proteins can be made. So the process in which DNA makes RNA is made from DNA is called transcription, and that takes place in the nucleus. And then the process in which proteins are made from RNA is called translation, and that takes place in the cytoplasm, specifically where ribosomes are. Also, remember that we covered the nitrogenous bases of RNA, specifically adenine, guanine, cytosine, and instead of thymine, like in DNA, we have uracil. So let's move on to transcription. The RNA that's transcribed from DNA is actually called mRNA. There's actually a few kinds of RNA out there, so today we're going to be talking specifically about mRNA. So the RNA that's transcribed directly from DNA is called mRNA, and then we'll talk about why after this week. So DNA, how do we make RNA from DNA? We are actually able, so if this side is a strand of DNA, how do we get to RNA? So you can probably guess that the complementary base for C is G, and then the complementary base for G is C. So I'm going to fill those in. What goes in here? Since there is no thymine in RNA, uracil can actually take its place, like this. And then for thymine, adenine is this complementary strand. So bases are added in this fashion to make RNA, the RNA strand. Let me reiterate how that's actually happens. So this is going to be a quick overview. Don't worry so much about getting the details because we'll go over it step by step in just a second. So here's a strand of a double helix of DNA in its ladder-like fashion. What actually happens in transcription is that an enzyme opens up. So actually it's kind of like this. Opens up a section so that it can access a part of the DNA. And then what happens is that RNA bases are going to pair up with the DNA so that in the end we get a strand of RNA that's complementary to that part that we were actually working with. So to go over that step by step, there's a enzyme called RNA polymerase, which is in charge of unwinding and attaching to the promoter region. Which is a region of DNA where the RNA polymerase attaches to and RNA transcription begins. Also, a couple important terms here are the sense strand, which is the strand of DNA that is used to transcribe RNA, and the antisense strand, which is the strand of DNA that is not used to transcribe RNA. So it's not used as a template, it's just the other side. So real quick again, RNA polymerase binds to DNA, unwinds the double helix, it binds to DNA at the promoter region, which is a section of DNA where RNA binds. It tells it, RNA knows a specific sequence where it should bind, and it binds there, and that's the specific sequence is called the promoter region. And then RNA polymerase unwinds the double helix of DNA. And the side that it binds to and starts making RNA from is called the sense strand, and the side that it does not bind to and does not use as a template is called the antisense strand. After it binds, so this is the RNA polymerase, this whole thing. Oops, no. This whole thing is called the RNA polymerase. And where it's binding, it's able to bring in RNA bases that are complementary to the DNA. So on this side here, you see the DNA, and on this side are the complementary bases that are being added by the RNA polymerase to make RNA. And finally, the RNA polymerase stops making adding RNA bases to make RNA at the termination sequence. Which is a sequence of DNA that tells RNA polymerase, which is a sequence of DNA that tells the RNA polymerase that you can stop here, we're done. So real quick, here, just a quick review. RNA polymerase transcribes DNA, so it unwinds the DNA and attaches to it, and then adds complementary RNA bases to the DNA in order to make an RNA strand. The sense strand is the DNA strand that is used as a template for RNA transcription, and the antisense strand is the strand that is not used. So it's just the other side that RNA polymerase does not bind to. The RNA polymerase binds to the promoter region of DNA, where it starts transcription, and it goes until it reaches the termination sequence, so which is the DNA region where it just tells RNA to stop transcription. And remember that the final product of transcription is actually called mRNA, or messenger RNA. So here's DNA, which gets unwinded. RNA polymerase attaches to it, and then complementary RNA bases are added, and then ta-da, we have a beautiful RNA strand. Alright, thank you for watching the video. Here's my little insect thing every time that I do. So insects are really cool in that they can metamorphosize, which means they change appearance over time as they mature. And one way they do this is that they transcribe different parts of DNA into RNA, so they are able to make different proteins. So that's what happens when a butterfly is maturing, or a caterpillar is maturing into a butterfly. It starts to make different proteins because it's transcribing different things. If you ever want to know more about that, just ask me, but that's all I need to tell you for today, and have a great weekend. Don't forget to do the Edmodo quiz and comment below on this video.